processor performance equation. Yeah. So this is a very important topic. Yeah. Not very hard, but very important. All right, so let's understand this topic. Yeah. All right, so first, so let's look at the CPU time for a program. For a general program, when we run it in the CPU, through instructions. So general program is compiled to a sequence of instructions. So in CPU, we need to execute instruction by instruction for the whole program. Yeah. So let's look at that part, the CPU execution time. Yeah. All right. So a program is composed of certain number of instructions. Yeah. And each instruction requires several clock cycles to execute. Yeah. Some instruction relatively complicated, so we need more clock cycles. But some instructions pretty easy, so fewer number of clock cycles. But we need to add up all the clock cycles for the whole program. Next, so the whole program needs a certain number of clock cycles to execute. If we can find the total number of clock cycles for the program, then we can get the total CPU execution time immediately, because each clock cycle has a fixed constant cycle time, right? It's fixed, always that same number, constant. So we do multiplication, so we get a final number. Yeah. Here, the formula, CPU time equals total CPU clock cycles times clock cycle time. That's simple. Yeah. So that's our first formula. Yeah. Then another version, yeah, look at this. Suppose we are given clock rate. How about that? Clock rate, not clock cycle time directly, but we know the reciprocal, yeah, it is the reciprocal of the rate, right? Yeah, some rate, okay? Yeah, also some frequency, some rate. Okay. So we have another version. CPU time equals total CPU clock cycle over clock rate. Same formula, but different format. Yeah. Next, our main concept, main performance concept in this part. Clock cycles per instruction, CPI. C cycle, yeah, the keyword cycle, per instruction, CPI. This concept, cycles per instruction, very important. Performance measure for CPU. Performance measure for CPU. Yeah. So let's try to understand this concept. First, instruction count. What's that? You count number of instructions for the whole program. Instruction count, IC. Yeah. Remember, after we compile a program into the machine language, okay, machine instructions, one by one, you have the total number of instructions. That is the instruction count, IC. Yeah. Here, do not get confused with integrated circuit. That's also IC. Yeah. But when we try to measure performance in this context, the IC means instruction count. Yeah. All right. So number of instructions to be executed for the whole program. Yeah. Straightforward understanding. Next one, clock cycles per instruction, CPI. it is an important measure for CPU performance. The meaning, based on the name, you can get its meaning. But it is a very important measure. All right, so now we want to calculate CPI, right? Calculate CPI, cycles per instruction. This is the formula. Total CPU clock cycles for the whole program divided by total number of instructions for the same program, instruction count, IC. Here you can see when you use this formula, your CPI, basically, it is the average CPI. Average CPI. Why I call it average? Remember, for different operations, the CPI could be different. Your program contains different types of operations. Addition, multiplication, division, load operation, store operation, right? Many different operations. Then, for each operation, their individual CPIs are different. So for that reason, this one is just the average CPI. So individual CPIs, average CPI. So then we will connect them. So we will get that processor performance equation. So that's the title of this part B.3, processor performance equation. All right. Then CPU time. So this time, if we use the CPI, we can get this version of CPU time. Instruction count multiply CPI, because this one gives you the total number of clock cycles. Then you multiply clock cycle time. So total number of clock cycles, because you multiply instruction count to the other side of CPI, so you can understand why we have this version of CPU time. All right. In this part, we have many formulas, but most of them pretty simple, pretty straightforward. Next, total processor clock cycles. So we want to look at the details, the breakdown of total processor clock cycles. Breakdown based on different operations. All right. So components for processor clock cycles. What do you mean components? Right? Based on different types of operations. Program contains many different types of operations. Addition, multiplication, subtraction, division, right? Load, store, for loop, right? Many different operations. Different operations have different CPIs. So we need to look at the individual CPIs. Here, let me just use a simple diagram. So this line segment represents the whole program. All the instructions for one program, and we, divide it into based on different operations. Different operations. So here, op1, op2 through op_n. Then for each operation, you have instruction count corresponds to that particular operation, and also you have CPI corresponds to that particular operation. So you have that. Okay. If you multiply them together, so you get a, so what's that? Total number of clock cycles for that particular operations, right? Yeah, that particular operation. Yeah. All right. So equals CPU clock cycles corresponds to that particular operation. Yeah. But we need to combine the CPU clock cycles for all different operations. So we get this formula. CPU clock cycles equals summation all the individual CPU clock cycles corresponding to all different operations. Yeah. But then using this formula, so we get this version. Summation, also summation, but each term, ICI times CPI sub I. All right, so this is our first equation. So we put here. Yeah. So we put here. We need to derive our final version of the, processor performance equation. Yeah. All right, so we get to this processor performance equation. When we start, here we just, put the formulas we need to use here. Yeah. First, the CPI definition. Yeah. From the previous slide, we have this CPI definition. Yeah. All right, so we can write in this way. Yeah. Then we need to use frequency concept. Frequency. Yeah. So in your program, the whole program, for each operation, each type of operations, each type, yeah, or individual operations, yeah, how much percentage of each operation with respect to the total operations, yeah, that number is a frequency number. Yeah. So this frequency here we define F sub I, frequency for operation I equals ICI, yeah, number of instructions for operation I over total number of instructions, IC, total. Okay, yeah. So with this notation, now we are ready to derive our processor performance equation, the final version. First, CPI. Yeah. CPI, okay? All right. Total CPU clock cycle, but we use this version to replace it. Yeah. So we have that formula. So we use that version to replace it. Then ICI part. So IC, yeah, so it's a constant. So we do the division term by term. So each term, so we do division by this IC, and this corresponds to frequency concept. So we get this version. Summation Fi frequency times individual CPI sub I. So this is the so-called processor performance equation. And this is the most important formula for this part B. All right. So our B.3, so I give you the concept. How do we derive this equation? In our last video, part B.4, I will apply this formula to solve one example. So you will see how do we use this equation to solve real-world problems. Yeah. I just give you a typical example so you will get an idea. Yeah. All right, so let me stop here.